We're moving on with Antoni Ivanov, staff engineer at VMware. Antoni will demo the creation of a data warehouse and create a star scheme using Kimball. And then he will use it in a simple machine learning model. He will discuss the benefits and downsides of using warehousing design patterns in machine learning. Antoni, the podium is yours.
Thank you. Hello, nice to meet you. Today, I'll be talking about practical Kimball data patterns. Before that, I'm working in VMware and also lead maintain our Versatile Data Kit, which is an open source project that aims to simplify data engineering and automate and abstract best DevOps practices and promote data practices. Though today's talk is not going to be about Versatile Data Kit. At the end, I'll mention it again, and I'll leave you to even homework that you can do if you want to. In the last few months, and in this conference as well, there are a lot of talks about GPT. Of course, GPT 3.5 really brought it to stardom, the whole generative AI. I don't know if it's as famous as Cristiano Ronaldo or Lionel Messi, but it's getting there. And in all these talks, we talk about how to use GPT, how to use generative AI, how to create them as well, models. But there's a lot of work also being done before you even get to the model, before you get to the prompt, and before you create your model. As you know, you need to feed it data, and that data needs to be with good quality. It's almost a cliche when we say garbage in, garbage out, but it's also a truism, like a lot of cliches. And a lot of those work, which we can call data engineering, collecting the data, gathering, getting the data, data wrangling, data transformations, are really important. Today, my talk is mostly going to focus on this kind of data engineering aspect. How do we prepare the data? And more precisely, how can we model the data so that we can use a reliable data in for any kind of use cases, ML models, AI, or simple BI use cases. So very quickly, I'll go over the data engineering and data science process. And then we'll discuss what is data modeling and one type of particular data modeling that's fairly popular, dimensional modeling. And then I'll leave you with an exercise about how we can follow this dimensional modeling practices that I will talk about. The whole data science process is fairly familiar. The whole data engineering process usually comes, you need to, of course, have a problem that you need to solve. In this case, asking interesting question. There needs to be some kind of business problem. And after that, you need to discover the data. That can be challenging, but you need to get the data from somewhere, right? In GPT case, they use a lot of scrape data and big corpuses of data. Regardless, you need to get it, and then you need to explore this data. Here I'm using the word explore really more broadly than you might. Here I'm talking about also how you need to process the data, you need to clean it, you need to remove any potential biases in the data. You may need to format it correctly so it's acceptable. For example, transformer models expect the data to be tokenized, and so on. And then here also, I'll be including data modeling the data. You need to model the data so it's in a format that's with good quality and reliable. And then you build and train your module, validate it, score it, and eventually when you're happy, you, of course, release it, and hopefully the users will be able to use it. This is the kind of standard process that we go to, and there's a lot of work that's being done is often you can do this even in a single notebook, like you just fetch your data, you do some cleaning, visualize it in your notebook, and then you even do a module in your notebook. There's a problem with this is that usually the whole exploration of data or creating your data model and the training, they really should be separated. Because the data model that you rely on in your training needs to be consistent with good quality and reliable, and it's better to think it as two separate processes. The same data model that you're going to use for training can be used by different data scientists in your organization, which would be able to also reuse the data. Otherwise, you can have some similar use cases which will produce different results. As an example, there was one team that was using customer data to try to predict how much capacity each customer needs to provision. VMware is a company that's dealing with the infrastructure. Another team was trying to basically estimate for some new feature how many customers would need to use this feature. They were producing different results because ultimately the first team was really interested in subscription-based customers, while the second team was interested in all types of customers. And because they were not communicating, they were not using the same data, but they're trying to create their own basically customer data model. They were producing different results, which when somebody at the highest level was able to see them was very confused, or when they start interacting with each other, were confusing until things had to be cleared up why there was a difference. This could be cleared up if you have this kind of consistent well-done data model that both teams can use for customer. And that's what basically data modeling, why it's important. If you look at the data engineering process, we need data sources from which we fetch some data and we process it. Ultimately, what we want to do when we talk about data modeling is we want to create this kind of consistent, well thought out model. It could be raw data. It could be also in the form of relational data, it could be structured or unstructured data. I mostly work with structured data in my company. So I'm going to focus basically on the use case for structured data. And this model, what basically I'm talking about, is very similar to what is talked about in data mesh when you're treating data as a product. We want this model to be discoverable, so you're able to easily find out, for example, in the example I gave, the customer data. It needs to be addressable, so you know how to access it, you know how to get permissions to access it, and needs to be trustable. Basically, it needs to have certain, I'm a primary software engineer, so I think about this as SLAs, service level agreements, but it needs to have certain level of agreement about what this model is showing, like for how fresh it is, what kind of schema it contains. It needs to be fixed. And most importantly, this kind of quality checks, or this kind of things, needs to be verified constantly in an automated way. And finally, of course, now once we have something that's reliable, it can be used in a BI project, data science tools, or ML model. It's very important, and that this, I'm calling it business model, we also can call it data product, is following these qualities. If it doesn't, there will be a lot of problems. It's even if you're working on your own project in a notebook, you can still do it this way by separating this process of data modeling and ML modeling. I think you need a separate processes and separate exercises. Dimensional modeling is a specific type of data modeling that focuses on particularly modeling the data into dimension and fact tables. It's a rather popular. there are different types of modeling, like both or in-mount and dimensional modeling is probably one of the most popular because it provides you a way to do this incrementally. We'll see how. So first, let's introduce what we mean by fact and dimensions. So in the dimensional modeling, you have this kind of two types of tables. We're talking about tables. The first one is the fact table. Let's use an example. Let's say that let's try to model simple business process in my case, and say that I will describe it as one sentence. Let's say that we try to model I sold 3 apples at New York at New York in 5 cents for 5 cents for $5, probably 5 cents too cheap. In this kind of sentence, you can see the sort of the verb of the sentence, which is sold, sort of describes our fact. Fact tends to be the things that's happening. You can have stateful facts, like I have a balance in my bank of $300. That's a state, or it could be action verb, like I sold an apple. Regardless, usually the fact would be described in the sentence by the verb. So this is a good way to be able to discern what's a fact. And the other type of table is the dimension, which is the descriptive properties of our business process. In my sentence, I saw 3 apples at New York. The descriptive properties say who saw them, that's me in this case. Where did they saw them, the location, that's at New York. When did they saw them, I suppose yesterday. This kind of thinking helps you structure when you're designing to model some business process, because ultimately when you're modeling data, you really model some kind of business process. The data comes from users. Users are using the data, producing it in some way, be it your user, customers, or random users. It could be, so when usually they're used in some kind of process or some kind of, and it's this process that we want to model. So now for exercise, I can try to, can you think of some ML project or data engineering project that you've thought about, that you've done recently or you'll be doing? Try to think of some business process that you need to model in your head. Try to form one sentence that describes this process. Like I mentioned example, I saw 3 apples, or I will board a plane at 3 o'clock on airline, Ryanair, with plane Airbus 330, something like this. Try to imagine it in your head. I'll give you 10 seconds. As you do that, you form a sentence that sort of describes your business process. You can probably, in this sentence, identify which is the verb. And this verb, around this verb, you can probably come with which should be the fact in your process, and then look at the sentence and think about what are the descriptive qualities of that sentence. Try to ask a question like who, what, when, where, how much, and so on. These are kind of the descriptive qualities. So around the verb, you can have your fact tables. So in your head, you're already modeling the fact, and the descriptive qualities, answering those questions, what, where, how, modeling the dimensions. So what are the benefits of overall dimensional modeling? One of the benefits, especially in analytical systems, is performance. Dimensional models tend to be fairly, especially if we're talking about star schema, tend to be denormalized, which means if you're using a rather modern analytics system, which struggles with too many joins, you can have fairly large type of queries on top of your model with very few joins. This help performance. Another reason is this kind of dimension modeling tend to be something that you can do incrementally. So right now, I designed a dimensional modeling process for the simple process of eye, salt, and apple. So basically, I designed the sales fact and the dimensions around this. Tomorrow, somebody else would extend this model by designing for selling, for example, cars or for selling some kind of software. So they'll be able to possibly reuse some of the dimensions like date and customers, and they'll add their own dimensions for the model that they need. And so on and so on. This kind of incremental modeling allows you to start building your model in a way that's step by step in small increments. Generally, it's very hard to be able to do something that's big bang, change the whole architecture, everything in your organizations at once. Incremental is usually the way, agile is usually the way to go in modern times. It provides you consistencies because you know basically the types of different data sets that you have. You know what is a fact and you know what is a dimension, and there's a simple way to discover what should be what. That provides a certain level of consistency, which makes querying much more easy. So for example, people, when they want to discover how many apples were sold in a given location, they know how very simply they can just query, give me number of apples, grouped by location, possibly. And this kind of predictable way of querying the sources make it easy for understanding and usage. And that means it can be much more easier documented, can much easier be tracked, and which is very important, as ultimately all the data that we use in model needs to be easy to understand, easy to track. Let's now talk about Kimball. Kimball introduced a lot of techniques about dimensional modeling around a lot of years ago, maybe around the time I was born, so that perhaps not that many years. And what I want to talk about, he introduced particularly 3 different things. One is architecture, the Kimball architecture. The second thing is the Kimball process, and the third thing is Kimball modeling techniques or design patterns. All those 3 things, they can be used independently and separate from each other, or you can use 1, 2, 3, doesn't matter. I'm gonna quickly mention Kimball architecture. So there's a link that you can read more about it, which will point you to the Kimball group website. But ultimately, the nutshell of Kimball architecture is that you have this kind of separation between the back room and the front room, and they also use the metaphor of restaurant. So I worked when I was younger in a restaurant a few times, and I've worked both in the kitchen where I had to peel shrimps and clean exactly next to me, or sometimes clean the dishes, which I didn't like. And behind me, people were cleaning potatoes, and the cooks were cooking, and it seems very chaotic. And you don't generally want your users, customers in the restaurant to see this. And there's a front room where I also work as a waiter, and where I was well-dressed, I was not sweaty. I was presenting food that was looking very good. I remember, for example, when I was working in the kitchen, I was doing breakfast. So when we're doing breakfast, we are doing eggs over easy, if you know them, with hash browns and bacon. So, for example, there was our sous chef was telling us that we need to put just 4 bacon pieces, no more, because that was what was, or no less, that was what the user expected. And you have to do egg over easy, you have to flip them, which is pretty hard. I would sometimes break them. It took me a lot of time to learn. So when you flip the egg, Sometimes there was one day that I was really very unlucky. I was when you flip the egg, you have to throw it away and start again if you don't do it successfully. So there was one day I was very unlucky, and I started breaking a few eggs more than usual. So once I decided to try to cheat and simply put the plate, to send the plate with the broken egg, but the waiter immediately returned it, telling me that customers would not like it. They have certain expectations. This kind of metaphor could be applied also for data modeling. So when you create your model, your users, be it the data science team who want to use this model for training, be it the BI team, they have certain expectations. And I'm going to call it a contract. And this kind of contract needs to be kept. And there needs to be quality assurance that ensure that this kind of contract is kept. In my case, this was the waiter, but in the data world, human QA doesn't really work. You need automated assurance that this contract is kept. So you need to have almost data contract that's automated way. There's a lot of talk about data contracts now, and hopefully we'll be able to the data community will be able to produce some working solution that will make it creating data contracts much easier. And ultimately, that's the nutshell that I understand for Kimball architecture. There are a lot more, so I suggest you read it, but is thinking about data modeling is by splitting the back room, the things that data preparation, data cleaning, and the front room where you want to present a data model, business model that's, that has certain expectations that the users would be happy with. The second thing is the Kimball design process. This is how you approach what are the data modeling steps, which we consider about the business and the data realities that you want to use when you're thinking about how to model your data, how to cleanly prepare it. It consists of 4 steps. The first thing, you need to really identify the business process. It always comes to what is the problem that you're trying to solve, what is the business problem you're trying to solve. And when you define the business process, we can come back to the sentence that I made you think. You can try to describe it with some simple sentence. Let's say that I want a model is boarding a plane, or I want a model checking account balance. That's kind of business process. Then you want to define the granularity of that business process. One easy way to try to fix granularity is try to think about this kind of sentence that describe the business process. So, for example, if you want to model I boarding a plane at 3 p.m. On airline Ryanair, the verb which describes the process tends to be an action verb. Most likely an action verb means that we want to track each event. This is called transactional grain because we are tracking each single event. But if our business process is something like my bank account balance at the end of last month is $300 at Bank of America, then the business process that we have a state verb, so most likely we have periodic grain. In this case, a month seems like the one. The third step is you want to define now the dimension. We'll go back to the exercise that we did in the beginning. We start when we're thinking about our business process that we defined as a sentence. We want to think about the what, the how, the when of our business process. So I boarded a plane at 3 p.m. On airline Ryanair using plane Airbus 300. The descriptive elements here are who boarded it, I. So we have a customer or a passenger, where they on which airline I boarded it, on what flight, from where to where. So this is other dimension, like passenger, flight, airline location. And finally, now we can identify the fact, which should come if you fairly easier. Said the fact usually tends to be around the verb of the sentence that describes the business process, like the passenger boarding event. That would be our fact table, let's say, or monthly count balance snapshot will be the fact table for the checking account balance business process. So these are kind of the 4 steps. You don't have to, a lot of teams in VMware that I've worked with, they don't necessarily use those processes in the same, some do, but to note, but they do try to think about all those four questions, categories, about what is of course, the problem, the grain, the dimensions, the facts, when they are modeling their data. This kind of structured way of modeling and thinking about the data model helps you create your data quality, which can only serve you better. And the last thing that Kimball introduced I want to talk about is the Kimball data modeling design patterns, or Kimball dimensional modeling techniques also called. This is basically, if the data architecture is really high level, something that, and the business process is something that you can do by yourself, but also you want to do as a team. This is something that when you're coding or when you're creating the transformations, you want to model a specific table, for example, specific fact table, specific dimension table, you can use, which allow you to have this kind of common problems be solved in a common way, which is what design patterns. For example, if you know that you want to use you have transactional grain, you use the transaction fact tables modeling techniques. If you know that you have some kind of more periodic grain, you can use either periodic snapshot fact tables. If you want to, for example, your account balance would be using periodic snapshot fact table, or accumulated snapshot table if you want to track how a state of something changes over time. And there are different types of knowledge dimension table. I urge you to check them out. And very shortly, I want to again mention Versatile Data Kit. Ultimately, Versatile Data Kit, what it does is a data engineering framework that enables you to ingest data, transform data using Python and SQL, and export data. And the second thing is it tries to automate a lot of this kind of DevOps for data practices. For example, automatic versioning, rollback, automatic release, separated between built-in code. Yeah. And Versatile, and what you basically want to show also is what I will leave you as an exercise to do is try to, I'll point you with a specific exercise, but try to think first as data modeling and ML modeling as two separate processes, as two separate things. And when you're designing your data model, which ultimately will be fed in your ML model, if especially something that can be applied in a relational way, what the features can be, try to use the dimensional modeling techniques that were presented here to help you create a model with better quality, make sure it's documented and you have verification and tests, that the way you expect the model to work is really the way it's going to be used. And then you can publish it, and eventually other users and other data science team can use it. And then you can focus on the memory modeling, where you do the training, validation, and eventually creating the model. So what I wanted to leave you as a simple exercise for homework is let's say that we work for Volkswagen or Tesla or some kind of, and they want to provide them as an app to make them to ability to plan their trip easier. So how much should you expect your battery to be drained if they drive with 60 kilometers per hour using heat and so on? They should be able to quickly say, so they can plan it. Something like this. So basically the exercise, you can try it yourself at home. So I urge you to walk you through everything we talk about. It will take about 30 to 1 hour. It can walk you through everything we talk about in a Jupyter Notebook environment, and you'll be able to hopefully get a bit better grasp of what is data dimensioning, what are the different Kimball techniques. So please do take, you can go to bit.ly/DCSdemo, or you can just pull out the QR code, and you can bookmark it, and I'll urge you later, you can yeah, you can try it out. If you do, there is a feedback form. You can also complete it. I'll wait a few seconds if you want to take a screenshot or bookmark it or open the QR code. Oh, wait. Yeah, okay. So that's everything from me. Thank you for having me. You can contact me, Antoni Ivanov, or you can contact us through, as I actively work on the Versatile Data Kit project. I'll be easily to get contact there as well. Thank you very much.